Good day, ladies and gentlemen. This is Sarah van Grinnen, aka Mr. VG, and I love this specific section in this topic about straight lines, the gradient intercept method. Now, this video is going to kind of form a very important two parts of the building blocks about straight lines, both for now as well as in the future. So this is a very, very important video because it starts off with studying the equation, the standard equation of a straight line. Now, the standard equation of a straight line is a function that is in the form y equal mx plus c. Very important that the x has an exponent to the power of 1. An exponent of 1. If it is an exponent of 2 or 3, then it is not a straight line anymore. Okay, then it's either parabola or cubic function that we will study in the years to come. But when it comes to straight lines, which forms the basics of all future graphs, you have to know that there are two specific things you can always read off from the standard equation. The first thing, ladies and gents, is the m value, which is the gradient of the graph. Okay, so m represents gradient. Now, another name for gradient you might have heard is slope. Is the slope up or down? Is it steep up? Is it steep down? Is it not so steep up? What is it? But the gradient is basically the ratio. Now, hear these words, the ratio between the rise and the run, or the change in the y values, that's the rise from one point in your graph to the next, divided by the run, your change in the x values. So we need to kind of just make a note of that. Very important. Change in y over change in x. I know some teachers don't really love that specific way of writing, but I love it. Change in y over change in x. So how the y values change versus how the x values change. The c value, okay, let's just go and say that the run, let's emphasize that the change in the x values. The c value is specifically the y-intercept of the straight line. Okay, it's the y-intercept. Now, I want to ask this, but why is that? Because remember that to get the y-intercept, I must make x 0. And therefore, I'm left with only the c value. So the c value is always the y-intercept. But, and here's that big but, the y must be on its own. The y cannot have a 2 in front of it, or a 3, or a negative, or there can't be x's on the left as well. Y has to be isolated. It has to be on its own, okay? Very important things that you've got to get, because if you don't have this, then this method of the gradient intercept method, listen to the words, gradient intercept. Need the m value, need the intercept. So I need to get y alone. So if I've got the function y equal to a half x plus 4, and I want to sketch it using the gradient intercept method, I must first of all get y alone. It's already on its own, 100%, no issues. Next up, I'm going to read off the m value, which is 1/2. And if I look at, remember, m is the gradient, so it's rise over run. Then I'm going to say from one point on the graph to another point on the graph, for every one value it rises, it runs two values. Now, please, we'll get to that in more detail later on. I'm talking very theoretical, so just hang on with me. Then the C value is the y-intercept, and that is going to be y equal to 4. So if I look at a graph, that y-intercept is going to be my starting point, okay? So always the y-intercept is your starting point. So that's one coordinate you have. Then I look from that point, that's my starting point. I need to rise 1 unit and run 2 units. So in other words, if I start with a run, that's your x values. It runs 2 units forward because it's plus 2, and then rises 1 unit up. So that gives me another set of coordinates there. Let me just make it clearer there. Okay? In other words, ladies and gentlemen, if I connect those 2 points and draw a line through them, that's what it looks like. Now, I wanted to just talk about gradients for one little moment, okay? Remember that gradient could also be 2 over 4. Why? Because it simplifies to a half. Or it could be 3 over 6, because again it simplifies to a half. So in other words, it is a ratio. Let me show this on the graph. For every 2 that my x goes forward, my y goes 1 up. So if x goes forward 4 units, then my y has to go 2 units up, because the ratio must be 1 to 2. So I could again go 6 units forward, but then I'm going to go 3 units up. So it's always a ratio, and it's always a fraction. Very, very, very important. Let's look at another example. 3x plus 9y, or plus y. Oh my goodness, 3x plus y equal to 9. What is the first problem? Well, y is not on its own. So what am I going to do with that 3x? Well, I'm going to subtract 3x on both sides. So this means that I've got y equal to negative 3x plus 9. What am I going to read off? Remember now, you need 2 things: gradient, intercept method. So I need the gradient first of all. But I want not just a value of negative 3, I want it as a fraction. So I'm going to say negative 3 over plus 1, because that's still negative 3. So this means my rise is now negative 3 while my run is plus 1. When we look at the sketch, I'll explain it better. What is my y-intercept? Well, that's 9. Remember, that's going to be my starting point. So when I draw my Cartesian plane, my y-intercept is going to be my starting point. Let me go back there. Let me go a bit slower. First of all, I'm going to have 9 as being my starting point. Then I'm going to run 1 forward. So only 1 forward, and I'm going to rise 3 down. So from that point there, I'm going to go 3, 1, 2, 3 down, and I'm going to end up with that coordinate down there. I'm just making it nice and clear. So I end up at the coordinate 1, 6. So to draw this graph, I'm going to put a line through it and write my equation there. So very important for the gradient intercept method. I'm always going to, number 1, isolate the y value. Then number 2, I'm going to start at the y-intercept. Then I'm going to number 3, use the gradient to find that second point. Rise over run. Ladies and gents, this is a crucial video because of these two things. You must be able to identify the standard equation and then use that with your gradient and your intercept to draw the graph. Man, I love this video. I love this because now we're starting to grapple more with what are straight lines. So have a beautiful rest of your day, ladies and gentlemen. Go and be awesome. Please tune in to our next video, which is going to go about determining the equation of a straight line. This is Mr. VG signing out. Cheers.